Now we're going to take a look at the binomial theorem. The binomial theorem is actually now something we've seen, and that is the expansion of 1 plus x to the power of n. So 1 plus x to the power of n is nc0 plus nc1x plus nc2x squared plus and so on and so on. Somewhere in the middle we'll have our general term nck x to the power of k plus, and we keep going till we get to the end, ncn x to the n. This could be rewritten in sum notation, so the capital sigma, which of course means sum of, and we're going from k equals 0, that would be the first term, up to k equals n, the last term, and that general term, nck x to the power of k. The actual definition for nck, n factorial on k factorial, n minus k factorial. And n is, of course, a positive integer. Just keep in mind, when you do an expansion of a binomial, you should always end up with n plus 1 terms. Well, the binomial theorem, as I say, is the expansion for 1 plus x to the power of n. We can extend that through to when, instead of 1 plus x, we have a plus b, which allows us to generalise it for any situation. So the only difference now, when we write the binomial theorem for a plus b to the power of n, we still have sum of k equals 0 to n. We still have the binomial coefficient, but now we have the a and the b terms. Remember, the two powers will always add up to be n, and we'll go a to the power of n minus k, b to the power of k. So if we had to work out 11c4, and yes, we have a nice button on our calculator that can work it out for us, but if we had to do it from our definition, so it's 11 factorial on 4 factorial, 7 factorial. Remember, we could roll out the 11 factorial, and we'd end up with 11 times 10 times 9 times 8, but then we'd have times 7 factorial. So it would cancel with the 7 factorial on the bottom. And if I roll out the 4 factorial, we can see a lot of cancelling happens here. Things like, well, 4 2s, that's equal to 8, so that cancel. 3, well, that go into 9 3 times. So I just have 11 times 10 times 3, 330. So whilst the button on the calculator is very useful, it's still important that we know the actual definition to work out our binomial coefficient. Find the value of n such that nc5 is nc8. This goes back to our Pascal's triangle relationship that we saw. If nc5 is equal to nc8, we're going to use the fact that Pascal's triangle is symmetric, and we know nck is equal to ncn minus k. So in other words, 8 must equal n minus 5. Playing around with that, n is 13. nc7 plus nc8 is equal to 20c8. Also comes from our Pascal's triangle relationship, which says to find any term, we add the two terms above it. So n minus 1ck plus n minus 1ck minus 1 is equal to nck. And looking at the numbers at the bottom, we could say that, well, k minus 1 is 7, k is 8. So n would end up being 19, the row above 20c8. Of course, if you didn't remember those relationships, you could always plug in your actual formula for nck and play around with the algebra on that. Find the fifth term in the expansion. So the fifth term k plus 1 will be 11ck, 5a to the power of 11 minus k, minus 3 on b to the power of k. So that's our general formula for the binomial expansion. We want to find term 5. Notice I said term k plus 1. And that's because the first term, the binomial coefficient, would have been 11c0. So 1 less. So if I say term k plus 1, it just makes life a little bit easier for me for working out the question. So term k plus 1, 11ck, 5a to the power of 11 minus k, minus 3 on b to the power of k. In our situation, k plus 1 is 5, the fifth term. So I'm substituting in 4 for k. So 11c4, 5a to the power of 7, minus 3 on b to the power of 4. Working that out, sort of, I haven't bothered actually calculating 11C4 and so on here, you'll notice. So an unsimplified answer would be 11C4, 5 to the power of 7, 3 to the power of 4. So an unsimplified answer is 11C4, 5 to the power of 7, 3 to the power of 4, a to the power of 7, all over b to the power of 4. If I was to work that out, we get 330 times 78,125 times 81, a to the power of 7 on b to the power of 4, and we get this very large number on top, a to the power of 7 on b to the power of 4. So sometimes it's okay to leave it in unsimplified form. Find or obtain the term independent of x in this expression here. Well, write out the general term. So it's always a good starting point for these sort of questions. What is the general term? So term k plus 1, 9ck, 3x squared to the power of 9 minus k, minus 1 on 2x to the power of k. The term independent of x. Well, that means it's the one that doesn't have an x. Or another way of thinking about that, x is to the power of 0. So if I just look at the x's, x squared is to the power of 9 minus k, and then I've got 1 on x, which is x to the minus 1, to the power of k. And I want that to be x to the power of 0. Playing around with our index laws, that means that 18 minus 3k must equal 0, k is equal to 6. Now it's just a matter of substituting into our general term. Term k plus 1. So it is indeed the 7th term, which will be 9c6, 3x squared cubed, minus 1 on 2x to the power of 6. In unsimplified form, I'd have 9c6, 3 cubed, negative 1 to the power of 6, well that's just 1, over 2 to the power of 6. Find the ratio of the coefficients of x to the power of 7 and x to the power of 5 in this expansion here. Yes, I could expand the whole thing out, but that would be quite a lot of work. General term. Term k plus 1 equals 15ck. You'll notice I've used the alternative notation in this case. And then it'll be 1 to the power of 15 minus k. Well, I haven't bothered writing that down because 1 to the power of anything is always 1. And then 2x will be to the power of k. So coefficient of x to the 7 over coefficient of x to the 5. Well, x to the 7 will be 15c7 2 to the power of 7. And because we were just worried about the coefficients, I haven't written down x to the power of 7. Then on the bottom of the fraction, 15c5 2 to the power of 5. Now this is where it's good to know our definition. So 15c7 is 15 factorial on 7 factorial 8 factorial. Invert and multiply 15 factorial over 5 factorial 10 factorial, but now it's upside down. And then 2 to the power of 7 over 2 to the power of 5, well that would simplify to give 2 squared, which is 4. Okay, we have some cancelling here. Obviously the 15 factorials will cancel. When I'm cancelling factorials, I basically look at it and say, which one's bigger? So on the top of the fraction, you see I've got 10 factorial, and on the bottom of the fraction, I have 8 factorial. 10 factorial is bigger. So I know the 8 factorial will cancel into the 10 factorial. 10 factorial will roll out to be 10 times 9 times 8 factorial. The 8 factorial cancels, and I get 10 times 9. Now, the 5 factorial and the 7 factorial. 7 factorial is bigger. So it would roll out to be 7 times 6 times 5 factorial. The 5 factorials cancel. I'm left with 7 times 6 on the bottom. And then I also have times 4. So to work that all out, we get 60 on 7. All right, I've got some questions here from 2 different exercises to play with the binomial theorem. But remember, the first step is very often just writing out the general term and then substituting in given information to solve the problem.